That's right.
Okay, hello everybody and welcome to the Portland PowerShell user group. This week we have Kevin Marquette going to talk to us about Pester, but before we get started, I want to thank our sponsors. I want to thank Viewpoint Software for giving us a venue, and I want to thank Sapien Software for providing the food. We'll do a little bit of in-person, interaction after Kevin has a chance to do his presentation. But until then, we'll give it to Kevin. Kevin, I'll ask you to just pause for about 10 seconds or so before we start. Thanks.
Inviting me to the group tonight, guys. So those of you that don't know me, I'm a systems development engineer at Amazon now, but I'm actually here presenting as a community contributor. So all my materials and ideas are actually my own here. So no. And so on that, I'm also a Microsoft MVP, 2018 PowerShell Community Hero user group. So I've been trying to be involved in the community quite a bit where I can. And I also present these user groups. So I was asked to talk about Pester a little bit as one of the topics I kind of like to present on quite often. And I was hoping that that's kind of what we'd run through today is, a little bit about what Pester is, how to get started with it, and some things you can do with it. So I suppose that's kind of it for intros, and I'm kind of ready to kind of jump into the slides or into the code here. If you guys are ready. Excellent. Okay, so as I jump into this, just so you guys know, I like to keep all my presentations up on GitHub. So if you're to look for this one tonight, it's actually Pester in action. And I have a separate branch just for tonight's materials. I haven't merged in quite yet. So if I go to branches, just to the PDX list here, this will be the most current stuff I'm actually presenting at the moment. So feel free to grab them, download the zip, and then you'll have a copy of these files. And I'll also say that this core presentation is actually more of like a two-part series. So I'm going to cover like half the stuff that I have scripts for in here, depending on how far you guys want me to go tonight. So with that, let's talk a little bit about Pester. So I suppose if you're not familiar with Pester, it's a testing framework, right? That's really what it boils down to is I have code that I want to test, and it's actually built as a PowerShell module. So if I pull up, let's have to open this up in a browser here. So if I pull open Pester Wiki, I will say that it is pretty well documented. A lot of the stuff I'm going to go through today, there's probably some good discussion points and things that you can pull from when going through the documentation. So, like I said, Pester itself it's actually just another module. So if I do get module, list available, Pester, it'll already be on most systems. So I say that because it started shipping with Windows 8 and Server 2012 R2. So this is one of the first open source projects that Microsoft actually shipped, out of the box. And but with that, I definitely recommend updating to Pester, pull the latest off the gallery. So if you just pull just like you would any other module off the PS gallery, it'll load the latest version. They've had quite a few syntax changes and the performance is much better now. So well, if you're just doing simple stuff, it'll probably work on the older version as well. But they've added enough improvements that it's definitely worth grabbing the latest version. So as to what Pester actually looks like it actually gives us an additional set of commands that we can use. That this is still PowerShell under the hoods, but they're given this additional syntax to describe stuff in a more natural language. And this is actually what you refer to as a custom DSL, a domain-specific language. In this case, the domain is testing. So what I'm staring at here is a describe block, which basically I'm going to describe something I want to test. So use the describe keyword, give it a description. And here's the body of what's going to be tested. It also has several it statements. So you want to describe what it is, and you want to say what it does. So this thing has an actual value. And then we actually have a test in here that uses several should statements. They're what you call assertions if you come from another language. But from a raw syntax point of view, this is the basics of Pester right here in front of us. And what's nice about it is if I run just this chunk of code here, it's actually doing the, let me run that again. So it renders cleanly. So it's actually kind of doing the reporting on here for you. So when stuff works beautifully, you get these nice green boxes with a plus mark. If it doesn't work, like I put in something else saying that this other value should be something it isn't. When it fails, we get nice clean error messages saying that that specific line there is what failed. I'd expected, the strings to be the same, but they were different. So it's kind of like telling you what's actually wrong with it as much as it can. In this case, it actually tells you what we said it should have versus what the actual value was underneath. And what this does is it saves you from writing that logic yourself, right? Like you could just as easily have an if statement that says something equals something else. And then your if and your else are saying and reporting back the status of what happens when it fails or it passes. And then you might want to collect the results or report them somewhere else. In a way, Pester gets to hide all that from you. So you just write your tests using their syntax, and it takes care of some of the reporting and details there for you. So jumping forward a little bit here, the should command is really what gives it a lot of the flexibility. Because I can kind of say this value should be this something else, this actual value, and it reads a lot more naturally when done that way. So I'm going to open up some larger examples here for just this specific command. So I'm going to have one giant describe block of should operations with several it statements for different types of commands. So here, we're doing the this value should be something else. And the way you'd use this is like, I'm just checking a variable here, but what you do is you run your command, right? Run a function to get a value back, change the state of the system, and use these commands to check the states are as you expect. So forgive my examples for being too simple at this point. We'll jump into some better use cases once you're more familiar with the syntax we're looking at here. So there's also a not parameter. So versus the to the negative test, right? Like something should not be something else. But there's a whole handful of operators that we can use here. Like if you need an exact match where case matters. You can say this should be exactly this string. And there's many other helpers, such as just saying that this path should exist, right? This is the same thing as doing a test path and checking if it's true or false. But this nice condensed syntax is what's, Pester's offering here. Sometimes it's not enough to know that a file is actually there. We might want to actually see that the contents have certain values. So here I'm actually dumping data into a file, and right away I'm testing this test drive to say that the file contents should have this string. And because and we're doing a match on this, it actually supports regex. So I can say I need the I to be the first character, some arbitrary letters in the string, and the word file at the end. And I don't care what's in here, and it should match this. And it will pass in this case because these things here would match this wildcard. If regex is foreign to you or is a challenge, don't worry. By adding regex, it does a lot of awesome, cool things, but it's also complicated, and you often add problems just by having regex. I have another post on that in my blog that goes into some of the ways you can use it outside of Pester. And then there is a match exactly that basically that ignores the regex syntax, because sometimes you're using special characters that mean something in regex that you need to use in your string match. And then kind of come full circle back to just a normal match operator, which were these previous two were checking the contents of a file. This one here is checking this variable. Like I can say, I'm a value, or if I had this in a variable, content that I got from somewhere, I could say it should match this regex pattern. So it's the same pattern I used before, but gives you ultimate flexibility on what you're looking for. And then we do exact matches that let you not have to worry about the nuances of regex. This one's a little bit more complicated, but sometimes you have code that should actually throw an error. And in a way it's important when you're actually writing your tests to not only test what you expect something to do, like the best case, you should also check the error scenarios, like cause something to fail in a way and know that and test that it should have thrown an error. So here's several examples where this line of code here should throw because foo's not defined anywhere, right? If I try to run that, I get a command not found exception. And this line here is basically saying, I fully expect there to be a problem here. Let's throw and recognize that. And we will allow this test to pass only if an error is thrown. I have some of these commented out as some that would fail the test. Like this one here, if I'm saying this should throw, but it doesn't, because I can actually assign a value here. Because he doesn't throw, he'll actually fail the test. And the same with the not operator. This works for all the keywords. So you either say something does throw or does not throw, depending on what your specific need is. And while you can write this for doing exceptions, by default, it expects none of your code to actually throw any errors. So if you're writing something with the only test of should not throw, it's actually recommended just to leave the code in there. It's perfectly fine to have a line that you expect to not throw, not test specifically for that case. And here's a case where I'm throwing something very specific that I'm actually want to catch or see that that's the thing that was thrown. Anyways, lots of options here. to play with if you start diving down that path. One that I actually use all the time is the should basically either be null or empty or not be null or empty. Quite often, I will get a result back from something and actually say, hey, where this value is, it should not be null or empty, and then actually go test actual values in it. So here's like process equals get process foo star, and my first line will almost always be something that says that the process should not be null or empty. And then I'd go on to do the next step where I'm saying process, dot name should be what I'm expecting here. Should match foo. So somebody's doing a quick null check, because if I get nothing back, I actually want to have this error down below tell me that my value is empty. Versus when I expect a value to match the word foo, that these lines each of these lines failing tell me something differently. So having more things to test for gives you more information when you're trying to figure things out. But yeah, so I'm a big fan of this be null or empty or not be null or empty. And there's actually quite a few of these commands, just to kind of highlight them here, that you can actually say something should be true or false. They should have a count of 4 or less than 5, or be of certain types. Now, these ones are definitely, many of the commands that I mentioned are part of the newer version of Pester, which is part of the reason why I recommend updating it right away. So if you tried to run this on the older version, it would definitely let you know that it's not supported. Actually be a syntax error because it's not a valid parameter in the old version. Okay, so there's a quick blast at the syntax and the style of the should operations. As we continue down into some other features of Pester, actually, let me run this real quick, just so we can see all these tests pass or fail. Invoke Pester is actually the command you call to run Pester tests. So before, I was actually able to highlight a section of the Pester code and run it as a way to quickly test and see what the results look like. But if we actually invoke a set of tests with invoke Pester, we get this beautiful summary at the end that tells us how long it ran, how many passed, how many failed, how many skipped, and pending. So wanting to know the summary data of what your tests contain, executing the full set of full command for Pester is definitely what you want to do. If you're being a more advanced use case where you're doing it in a build release pipeline, you can actually do pass through to get some objects. There's plenty of parameters on here to do some more advanced stuff with it, like enabling exit. Like if it fails and you want your pipeline to fail based off of return code, you can use the enable exit option, but if needed. So a couple other features here is that we have another keyword in here I didn't mention before, but it's more of a way to subgroup or group together sets of tests. And it's really just another nesting layer to give you this resolution here. All right, let's give that a shot. Yeah, so I get the describe block to begin with. And then for every context, it nests it in and groups tests together. So quite often I'll have a long series of tests that are very specific to a certain test case or condition. I'll wrap those in a context that just when I'm looking at a large list of results, this can add a little bit more information to yourself. Now, they recently, Pester 4 added a because operator, which actually lets your error messages give you even better messages. So by default, it'll check a few things. Like, so if I run this guy here, it passed, everything works as expected. But let me change this to something else. And I run the same test to see it fail. It's going to say, so I got everything to fit just right to see the output cleanly here in VS Code. That we expect the strings to be the same because we use the because. And the reason why is I said so. Like, this is a string from here that I added to my output to make sure my errors give me better information. Now, this seems like a trivial example because the basic message looks pretty good. But sometimes you might have tests that the error itself doesn't really tell you where it came from. So I'm going to get this one here that should randomly fail because I'm doing some random numbers here. And so I expected something to be 0, but it failed because of main test case. So by reading this now, I know that this point is where it actually failed. A better example, do I have one on here? I don't, but a better example is where you might be testing the same thing over and over, but you're doing other things in here that might change the state of your test or your environment. More specifically, you might have something at the beginning that's doing the prep or the setup. And you might say, hey, I expect this to be here because of this is my starting condition. And then I change something. So this is my main test case. Or at the end, it's just double checking the details are things you could say in the because statement so that when your tests fail, you can instantly know right where the problem was. And it's mostly because like this line here will show the same thing no matter which, by default, we give the same error message. So if I run this a few more times, so main test case, some assumptions. Oh, this one they all passed. So yeah, that's random for you, I guess. The test drive. I flashed past this before, but Pester actually gives you a private test drive so that you can do temporary file work and know that it's going to clean itself up afterwards. Like, if you're going to like create some file to run a test and your test fails, Pester is going to stop running your test at the failure point, which means you might not get to your cleanup code that might happen after that test runs. So in a way, by using the built-in test drive, Pester will say, drop whatever files you want in here, and I'll take care of cleaning this up after the tester ran. This test drive itself is actually mapped into your temp folder. So it's just a PS drive. If you do like a get PS drive, but it only exists in the context of this test. So after Pester finishes, the drive goes away. And there is, I think I mentioned it later, but if you are working with something that does not like the PS drive, because because you're doing like .NET objects or something external to PowerShell that you're handing this information to, there's also a variable called test drive that is basically the same thing, but the full path off of your C drive or your temp folder. So if the shorter syntax for this PS drive is giving you fits, you can flip over this test drive here to get the same thing. I see that with, especially with .NET objects, like you create an XML object and you call it like the xml.save. That command being .NET has no concept of what a test drive is or what a PS drive is, and it will complain wholeheartedly. But let's say you actually do need to do some cleanup. There's actually, or some special stuff like, here's a case where I want to actually drop something unique into this test drive for multiple different tests. So here's where I'm starting the pattern of, before each test that I run, give me a known file in a known location that whatever I change later will get wiped out because I'm running this for every single test. So in this case, my first it is actually verifying it exists, checking the contents, actually changing it, and verifying the change. On its own, if I didn't do this before each, it would continue on to the next one, and my state has been changed on me. So my second test will fail, even though I need something consistent for every test. So ideally, you shouldn't let tests fall down to the next one. Like, your states really should stand on their own. So if I need something consistent, a before each is a good way to say, give me the same thing over and over that each test can just depend on. That way, at any point, you can just drop in a new test along the way and just know you're not messing up any of the other tests. And there's actually a whole slew of these. You can do before all, after each, or before all, before each, after all, and after each. That way, you get the granularity to do exactly what you need to happen when. If I run this block here, we'll actually see it's, I'm using right host here, so we can actually see each of these executes in sequence here. And let's fix our window. So, yeah, so here's my describe block. We did the before all, before each, the first it, after each, and then actually I had an error in there, which actually threw after the each had run. So, well, I designed this so that I would get an error here, because I'm throwing an exception. Pester will continue on and do the cleanup, the after each step, before it bubbles that error out. So by the time I saw that message, the after each statement has already ran. So that's what this example here is. It'd be a fun one to play with, to kind of see exactly where those happen in the order of things. And then a little bit more of an advanced feature that people don't use very often, but I don't know how many of you made it to the PowerShell Summit last year, but we did this Iron Man scripting challenge, and only one team used a test case in their Pester test, and that really stood out amongst the others. And there's kind of two ways to approach it. So first, I'm going to show you the kind of quick and dirty way, where I have this basically this array of hash tables. And really what I mean by test cases is I have several things I want to test, but I only want to write the code once, right? Like, I shouldn't have 3 separate tests for each one of those. It's just the data that's changing. So here's a case where I'm doing a for each loop over the test case and just creating an it statement for each one of them. right? While this works and gets the job done, and there's sometimes creative ways you can use for each to do this. There's a built-in supported way with a parameter here. Okay, so I'm gonna slow down on this one. So I've got my normal it block with my statement, and I'm passing it a test case variable that's gonna actually execute this whole block once for every item in that array. So here's a case where if I go back to this first one, we can see that I handcrafted this in a very special way here. So I actually have an array of hash tables. And your test cases have to be this way. It has to be an array, a collection, and the items need to be hash tables. So if you had any other object in there, it's not going to work for you. And so here I've got 3 hash tables. I got a 4th one here that would fail if I included it. And I get back down to here, the way it works is as it walks through each one of these, it's actually effectively splatting that hash table into this parameters block. So the alias and the command are splatted from these parameters in this hash table. And we have this token syntax in the statement so that when these run, it substitutes those in so it's unique for each one of those. So let me run this example here. And we're actually going to get 1 for each one of these. So it's looping over each one of these. It processes them, it splats them. The patterns are substituted in. And to prove that it actually works, I'm going to do an invalid one here, like an alias that feels like it's right, but really isn't. So I'm adding a alias to my list. If I run our test case now, we'll see that it runs multiple times. Boy, VS Code. Keeps redrawing my host down below on me. But ran the first 3 plus this one, and I get the exception that gets dumped out here and the message from what I was using. I expected get my object, but I got nothing. And every once in a while, you can do a more advanced use case where you need to reach inside of a module and do something internal to it. Like maybe you have a private function that you need to test. And Pester actually adds this in-module scope, which basically says, inside this module you name, inside the scope of that module, run this set of tests. And here's the case where I grabbed Pester because I know from poking around in it, they've got this variable called save commands. Like if I just run it here, I get nothing back because it's not in my current scope, right? It's literally inside that module. And if I run my test here, this will fail because I'm not including the in-module scope, right? But by including this, by including the in-module scope part, it's actually inside the module is beautifully executing this test, and it can find the command it's looking for. And then the last keyword here I kind of want to show, and I got some good examples of this one, is the mock keyword. So mocking is a way to take an existing command and effectively replace it just for your tests and make it do something else. And the get date is a good example only because sometimes you need a consistent value to come back to know that your tests are doing what you want them to do, right? Like if you're just doing get date, how can I ever test that the date is a certain date, right? Now, this is kind of a silly example in that you don't need to actually test the results of get date because you're telling it what's to come back. But it stands in for something else that might depend on it, or some other like nested commands that you need to not actually take any actions. So for example, maybe you're off the domain and you need to test something that says, get AD user or get AD computer, right? Like I can write a test that gives me a fake object back that doesn't talk to my real domain. And then I can actually use a special method here to see how many times it was called. So let me jump into a different script here. I kind of built this one earlier here. So, all right, so in front of me, I've got this more like one of those more like operational scripts, right? Like, so here's a case where we can make good use of Pester. Let me just hide that for now. So what I have in front of me is a script that basically gets a list of servers and patches them based off of the day that the script is being ran. Okay, so let's walk through this script real fast. Like I'm using a CSV. This could be, get AD user or query wherever your servers live. But for the demo, I hard coded a list of server names. So when I check this guy out, I have a name and a wave. This is my object. So I basically have a list of servers that I want these guys patched in wave 1, these in wave 2, wave 3, wave 4, and 5. In production, I got those split in half, like a nice solid test patch deployment strategy. So now I have a mapping of when each server should be deployed, and maybe this is your Active Directory groups and OUs, or some other system, your SteamDB, that tells you the schedule of these deployments. I grouped them in waves for kind of simplicity here. And then let's come up with a schedule. So in this case, I've got a patching group schedule of saying, at wave 1, I want this to be 2 days after Patch Tuesday. So I'll make everything relative to Patch Tuesday. So this will be 2 days after, 7, 9, 14, 16. So basically, like Thursday, the next Tuesday, the next. So I kind of like staggering them out so that you're not patching everything at once, right? Get a good feel for what's working where. And if you notice my waves below, my wave 1, darn it, VS Code. My waves are kind of correspond to the value of my environment, right? Like in this case, I have a dev, QA, UAT, and production as some of the dictated waves I wanted to pick for stuff. So let's go and load these. Then getting Patch Tuesday. So basically, I need to figure out what today's date is. So I have a get date command. I want to know what right now is. And then, I've got a safety check in here that this script must only run between midnight and 6 a.m. That way I can't accidentally run this midday. Who knows if it's a scheduled task and it fires it off. So let's have that check in there. So here I'm just testing the hour of the date. And then I've got some complicated logic here that's doing some weird date math to basically figure out the second Tuesday of the month. And then I figure out how many days we are from Tuesday. And then finally, and then I walk that patch group, that schedule, to figure out if there's something that matches today. So let me load these variables so you can actually see some of these values. So I've got a date. This will fail. Oh, no, this will be true if I'm returning here. So it's not going to do anything, but we'll continue on. Let me load my complicated logic here. Who knows if there's a bug in there? Maybe we'll test for that. And then, all right, so let's check our value. Our second Tuesday of the month happens to be September 10th. Yeah, that works for me, September 10th. So my math apparently was right. Then how many days from Tuesday are we? We are 9 days. And let's find today's patch group. So 9 days, if I go to my list, 9 days, I expect wave 3, right? So I come back down here. And what was my patch group? Wave 3, okay. And then my list of servers, right? We do our filtering. And then I actually got some complicated logic here to actually run the patches. In this scenario, actually, I plucked this from another environment I used to manage. We'd basically use SCCM, where we'd push the patches down to the nodes. And then we'd use these commands to see if there's any updates available and to actually run the updates. But basically, I'm executing the update command I need on the system. So this is a very operational script, right? I'm sure you can imagine yourself having something like this that has lots of entry points and different things that is actually really important. If your patching script gets hosed, how do you know it? How dangerous is it if this thing actually runs at the wrong time, or the schedule isn't actually what you think it should be, or you got bugs in it, or you make changes to it? How do you test it, right? Do you actually have to stay up late on the Thursday after patch Tuesday to see that your script worked? So to complement that, I create a set of tests that kind of shows you how we can pull all that stuff together to test this script. So I'm starting by mocking the import CSV, right? I'm doing this because, yeah, I could import the same CSV, and I'm using this as a stand-in for whatever your server system is, which if it's AD or something else, that could be a live list of servers that might change on you. And one thing you don't like in your tests is your data to change unexpectedly. So first thing I did was decide that I'm going to mock the import CSV, because that's the command I'm using, to give me a known set of servers that have the names and the waves that I can depend on for the rest of my tests, right? I can't tell you how many times I've tried to use live data. I had a test server that I test against, I get from AD, and somebody would delete it because it wasn't a real server, right? Having my data being dynamic and trying to represent something real that other people can change and manipulate can really wreak havoc on your tests. So, so here I'm mocking my import CSV, mocking your getAD, whatever your source is. And then I'm going to actually mock these other two scripts that actually are doing the updating, right? So if I jump back to my script here, when I test this, I don't want to actually run the update. I just want to know that these correctly ran. And that's kind of where mocking comes into play, is that not only does it give me consistent data coming in when I mock the import CSV, but by mocking the commands that change the state of my system, I can safely run the script without it changing the state of my system. So in this case, I get some instance and I need to have a value in there because it's a parameter. And then I execute this command. Now, I definitely do not want to run this in production. But even if I do by mistake, this data gives me completely fake servers that aren't real. So if it did happen to run this data set, because I faked the data set, it's at least not hitting and targeting live systems. So live systems were never part of the data set to begin with. Okay, so I'm mocking a get sim instance, a little trial and error on what to return back. Sometimes you don't need to return anything, but sometimes there's properties or parameters you may want something may look for or test. So in this case, I wanted a hash table of properties here for something to look at later. So I hard coded it to just a hash table giving me a status 1. And then my invoke sim method, same thing. I don't think I even need the true on this guy. In fact, I'll leave him off. Should I leave him off? I didn't test that. Well, we'll see. We'll see what the tests tell me. Mock verifiable is just a keyword that tells Pester to keep track of how many times this is called, because I want to verify that these things were called. So let's do the test the first wave. So I've got my test, right? It updates the first wave. And this is the case where I'm actually mocking my get date because I want it to test what would happen if I ran the script on 9/12, which is 2 days after Patch Tuesday. I picked that date on purpose. And based off of the data set that I've hard coded, after I run this script, I know that the get sim instance command should only run one time, and the invoke sim method should run one time. Okay? So what that tells me is, if it runs 0 times, this got skipped, right? That somehow it did not find my servers. If it runs more than that, it found way too many. Because I'm intentionally choosing what I know is the first wave. If I look at my data up here, this is the only server in wave 1. I got wave 2 and wave 3. So I have extra data in here to make sure my filtering only grabs what I want to filter on. So this test, I've got extra data, but I know I'm only going to try to select one thing. So when this runs, it should say it only ran one time. The scope here says that the scope should be within this it statement. You can actually scope things to much larger, like the context or maybe even the describe. But generally, I want the scope of where I'm calling this, which basically means don't count anything that happened outside of this it block. So there's my first test. Now, we should probably test another wave. So here I'm going to test what happens on the 17th. So I'm, again, mocking get date, telling it to do something different now. Always give me this date. And because this is wave 2, this is 7 days after wave, I know I have 2 servers. So both of these need to execute 2 times, you know, not 1 time, not 3 times, 2 times. And we should probably test an edge case or a different date. Like I want to test the 15th, which is no waves at all. So it's just as important to test your data sets is to test the, the non-happy path. So on this day, I want nothing to update at all. And that's what I'm going to run here is on the 15th, let's run this and check to make sure that those commands did not get called at all. And then my last test to finish it up is say, oh, let's make sure it doesn't run in the middle of the day, right? Like I added that trap in there on purpose. So I'm creating a date time at 2 p.m. So this is 2 days after. This is the patch 2 wave date and 2 days after. So now I've got 4 tests that really tell me a lot about how well this script is going to work. And when we run this guy now, what is it? Let's see what our output looks like. Oh no. Oh, I know I did. CD updates all in one. It's doing a dot source in the local folder, and my folder didn't match that. Generally, you do some other logic to account for that, but in this case, for the demo, I threw it together fastly. And here's a script that I can now safely make lots of changes to. And I can test and know that my logic is working and it does what I really want. So that kind of like that's how it all pulls together for your operational scripts, is that like now I can change this guy over and over, make quick revisions, and run this invoke Pester here to see that I didn't break anything, to see that I'm only getting the servers that I want to get. And it's a way to really protect your changes going into production in a way like sandboxes in a nice little bubble here. So I think with that, I kind of want to open the floor up to questions to see what questions you guys have, where we want to maybe loop back on things, or ways you guys see you might be able to leverage something like this. Yes, I can. Yes. Yes, I am. So the question was, am I familiar if I worked with the Gherkin syntax at all? And I actually have a blog post on it. So if I go to my tags, probably Pester, Gherkin. So here I've got a few posts on where you can do like the specification and what the invocation looks like. So to quick contrast this with Pester is, Gherkin is a way to give you you define this text file like what the it blocks are, right? You describe your tests in the syntax that says, given when we have a source file and we have a destination folder, or when we call this item, then this happens, and this is the original file. Like you actually, in raw like Notepad, you can write this. And the value is that team members that aren't able to actually don't even know PowerShell at all can learn the structure and the syntax, where your manager could, like a manager can read this and say, yeah, I feel like that meets the specifications of what I want us to do here. And so it's readable at the manager level, if you will. But then behind that, so when you run it, like in this case here, it's going to just error out because I actually have no code backing that up. So when I actually go to implement it, it uses an alternate Pester syntax. We actually say given, and actually type the sentence that matches your specification file, and then you put the test inside there. So given we have a source file, given we have a destination folder, and when we call copy item, we have a new file in the destination. So I will say for people that have a hard time wrapping their head around Pester or just don't like the structure or the feel of it, it might be worth taking a peek at Gherkin, because I believe there are like two sides of a lot of like testing methodologies. So if one methodology pattern doesn't fit well for you, there are people that really find that Gherkin is actually an alternate that they can tolerate much better, if that makes sense. Yep. Okay. Actually, let me take 5 more minutes just to kind of wrap something else up here. Is that I really just dove into the syntax and the style of Pester. And this example I gave here was very much around testing a script. But you can test just about anything. So if you are curious, I do have more files in this repository. And especially in my other, I have some like operational validation scenarios where let's say I'm deploying a small lab and I need to have a certain OU structure, like where I have students that mess stuff up. I want certain, OUs, groups. I want certain services to exist. Like you can call and test just multiple things. So I've got small examples out here of like, here's a SQL Server setup where I know I'm glossing over this now, but here's one where I'm actually saying, hey, do I actually have the drives that I expect in this system? Or is it the right version of SQL Server, right? So here's some validation tests that you can add to your toolbox if you're not using DSC or something to complement DSC, because DSC is great at studying the state of something, but it can't tell you the status of if something's working correctly or not. My best example is you can use DSC to set up a website, but it won't tell you if the content that's coming back is the right content. Pester can say, hey, is my port open? Is I getting content? Is the status code what I expect? So there's ways that you can use Pester to complement your infrastructure testing. So it's not just about testing scripts. It's literally whatever your imagination can test against. So I think with that, we can kind of wrap it up here, but I do have lots of examples in that repository, and including this update one that I actually threw together today for this demo. So I welcome any feedback you guys want to send my way. And if you have questions later, ping me in Twitter or whatever, and we'll see what we can do for you. Okay. And if you have questions later, ping me in Twitter or whatever, and we'll see what we can do for you.
All right. Thanks a lot, Kevin, for coming and presenting to us. This is more than once that you've come and helped us with our presentations. So much appreciated. At this time, we're going to close up the stream. We'll do all of our in-person stuff. If you would like to know what we talk about, then please do next time. Come on down. If you're watching the stream in the future, hope you like it. Thanks, everybody. Bye.